Okay, so our paper focused on automated facial expression recognition. And so the goal is to attempt to recognize the six basic expressions or facial expressions, which are anger, fear, disgust, joy, sadness, and surprise. A lot of the current methods out there today focus on engineered features such as Hog LVPH and Gabor filters, and they really lack this generalizability into in-the-wild expression recognition. So a lot of them are tuned on a single database, which means that each database has a fingerprint of light and pose. However, in the wild, these database conditions don't exist, and so we don't see the accuracy of recognition that we traditionally do. So our proposed method uses deep learning and deep neural networks to improve the generalizability. And the way we evaluate it is in a cross-database manner. That is, we use 5 or 6 databases to train the network, and then a second or an alternate database to evaluate the network itself. When we were designing our network, we focused on local feature recognition in the network design, which is something that humans use or humans do very well. And we also focused on reducing the number of network parameters so we can use it in applied scenarios. To do this, we used an inception-like layer style found in the GoogleNet architecture, also network and network architecture, which allows us to really achieve these two goals. This is our network. It's rotated 90 degrees, so no one can read it anyways. But it's stacked. It's 3 stacked convolution inception modules, precluded by a stack of convolution layers and followed by a classifier. So our experimental methods, we prepared labels on 7 databases and then did some pre-processing. These are some examples of the expressions which are available, or some of the pre-processed images, and you can see really the difference in pose and expression. So we got these results on our database. We had very strong results comparable to state-of-the-art accuracy, particularly SFEW, which is actually a database which is in the wild itself. So we had very strong results in SFEW, and this is subject independent, so this is our traditional evaluation. We also did cross-database results, which you can see there's not a lot of results out there in state-of-the-art. However, you can see that we have very strong results even in cross-database. So these are networks that are trained on images that don't see in a database and then are actually available to it for evaluation. We actually have a real-time demo of this. I'm actually not very good at making faces. But this is run on a laptop, so we have very strong, very small network with pretty good generalization accuracy. It doesn't do disgust real well. I'm trying to do sad, and it's I'm not very good at it, according to the network anyways. So in conclusion, we established the validity of deep learning in the inception-like layer in facial expression recognition problem. We also worked to generate strong cross-database results on a wide number of data sets. Well, we also wanted to maintain that subject-independent accuracy. And then also we have state-of-the-art performance with very few operations. As you can see, this was runnable on a very low-power device, which makes facial expression recognition accessible. Thank you very much, and if you have any additional questions, I'll be available at our poster session.